Now members, we are going to see detailed examples in moving averages. So I've done some parts. Now we are going to just go through as I explain and we do more. So here the question is, the table below shows the amount of water used by a given institution for a period of 6 months every year from 2000 to 2003. So this is the table. The questions are here. Calculate the 3-year moving average for a given data, plot the data, the raw data, and the moving average. Then comment on the volume of water used in a period of 4 years. Use the graph to predict it in cubic centimeters. Water to be used in March 2004. You see from here, it shall go to 2004. Now, here, of course, you get our data. This is the data given. Now, this is what we call the raw data. What you get it, and you put there. After we plot. Now, to get the moving averages, now here they want a 3. So it means that we take 3. So 1, 2, 3 is going to be our first average. Then you drop this and you count the next 3. 1, 2, 3 is going to be the second. You drop this. So that's you drop as you add. So the third is going to be this, and this. So you add this plus this, then divide by 3. Then you drop this. Now you add 54 plus 45 plus 60 divided by 3. This is what you get. You drop this, 45, 60, and 42 divided by 3, this is what you get. You drop this, you get now 60, plus 42, plus 69, divided by 3, this is the answer you get. When you drop this, you start you'll be having 2, which can form a set of 3. So you stop at that. So that's how you calculate the moving averages. Now after moving averages, calculating them, then they're telling us that plot. Then plotting, you say you give the scale if the question doesn't give you the scale. So I'm saying when you see my figures, it's that I'm between 30 and 69. It means that now I can start from 20. So 20 now will be using the scale of 10, 10 for every 2 centimeters. So 10, 30, and then 20, 30, 40, 50, 60, 70. So you can choose your scale because your graph is a bit longer than mine. Yeah, I'm having a little space. Now, the vertical, I'm using 10, so every 2 centimeters, there are 10 cubic centimeters of water. But now we need to know what each small square represents. Now, each small square, you know, remember every 2 centimeters are having 10 small squares. So by 10 small squares are equal to 10. So from here, you see that for every small square we have here, it's going to be having 1 cubic centimeter of water. Not 5, we have 1 cubic centimeter of water. So we divide this side. So here, remember we have 10. So 10 small squares on the vertical are not be equal to 60 marks. What about 1 small square? Divide 10 this side, you have 0.6. So here shall be with 0.6 marks. So 0.6 there. 0.6. So on the horizontal. Now after doing that, we come and we do the plotting. So the plotting here is plot. You start hour 30, the water of 30 goes with March 2000. So that's why I'm having March 2000 goes with that. This is how we plot. You group 2000, 2001, 2000, 2000. Remember the numbers predict, that's why I'm having. Now the next from 2004, we shall go to March of, from 2003, we shall go to March of 2004. Now, here to start with, because this is March 2000, I need to start, you can put here a value so that you don't leave some space there. So if this is, you start after March, you go to October. It means that now, this March was coming after October. So October, but of which year? Of now, 1999. That's how you can give that. If at all you don't want to, you want to define the scale. Then plotting, this is that just simple plotting. March, so that our March here goes with 30. You see that March goes with 30. So our March in 2002 goes with 30 there. When you come to our October, it's 48. When you come to our March 2001, it's 33. March 2001 goes with 33. You see the value there. this protein, just simple protein, until when you reach the side, when you reach in March, October of 2003 is 69. October of 2003 is 69. As simple as that. You see, when this is 69, it's going to be there. Then you join them using a ruler. Join this, join there, join there. And here I will find that whenever I have this is called, this is my row data. For it I'm using stars. Now let us put in the moving averages. So the first, now these moving averages we count. So here we are counting them. So you count the 3. 1, 2, 3. Their middle part is here. So it's going to be October. So the first moving average is going to be with October. 1, 2, 3. So where is the average of the 3? It's going to be here. So now it means that this one is going with October. So this one is going to be now October. So October of 2000, this October. So I put this October, then it's going to be 37. My 37 is going to be close to this 37. It's going to be somewhere there. Then for them, I'm going to distinguish by using a dot across the point. Now the next, of course, if the first is going to be here, the next year, up to the last one, which is going to be there, as simple as that. Last is going to be on March there. So they are going to be crazy. You count 3. So if you count this 3, remember when I close this, I'll be having this, and this. Where is the middle part? It's March. So you start we are going to March. When I close this, I go to this, and this. The middle part is October, part of 2001. So that's how you put the moving average. So next is going to be in March. It's where? 45. My 45 is somewhere here. So that's where my 45 is. Then I close it. The next is going to be 44. But on the next month, which is October now, 44 is a bit below this one. So this is my 44. It's a bit below. Then I come to the next is 53. My 53 is somewhere there. Then I go to 49. It's going to be October. 49 is a bit below 50. Below 50. That's where I'm going. Your graphic can easily put them. Then 53, the March of 2003. That's where my 53 is going to be. 53, yeah. It's exactly there. Then you can close. Now here, we say you draw a line of best fit. I think we have seen how we do line of best fit. It covers, it's the line that ends to all the points. So you see, when I draw this, when I put it passing through this point and this point, you see it's going to be my line of best fit there. When I draw it there. So that's going to be my line of best fit. We saw how we do this. But now, to join them, for them I'm going to use dotted lines so that I can differentiate. The lines here. Let me use dotted lines so that I can differentiate. So that's how I draw my line of best fit. So here I put this. This is our moving averages. So after doing that, I've finished that. Then I come to this one. Comment on the volumes of what I use. So now we start. The line of best fit, we say it has a positive gradient. So the comment in part C, there is a general increase, in water used over period of 4 years. Why do we say it's increasing? Because Rn is having a positive gradient. Then this question is telling us that use the graph to predict amount of water used in March 2004. So our March 2004 is the next coming after, from March to October to March of 2000, from 2003 to 2004. So you just come, remember our line is there. Then you draw a line from March of 2004 until when it touches that line, right? You see there. Mine is touching there. Then from here, you draw a line straight to that point and see the value that you read there. So mine is here, we trace that line. Now, remember with this way, I already am on top of water. So then you put there, then you draw a line. Like the sun doing. So now you know that line should be straight. So me, remember every centimeter is representing 1. So me, what I get there, I'm seeing that in March 2004, we shall use 62 cubic centimeters of water. Why? Because I said every one small square is representing 1. So start these are 2 small squares. So 60, 61, then 62. So it means that in March of 2004, we shall use 62 cubic centimeters of water. So that's how you can predict. Use the line of best fit from this, that is the line of best fit, then you read off that value. So the trend is increasing, so there is a general increase. So that's it, members. We are going to see the next example on the next lesson. I wish you well.